Suppose we wanted to delete element 5 from this array. How would we do that? So the way we would do it is we would override 5 with 7, then take out 7, replace it with 13, replace 13 with 21, replace 21 with negative 20, negative 20 with negative 30, negative 30 with 15, replace 15 with 10. So this is basically how we would delete from the beginning of the array. And as we saw, we basically had to go through all the n elements of the array. So it takes big O of n time. So the time taken is linear, where it's basically depends on the size of the array and the number of elements. More importantly, the number of elements within the array. The size could be anything, but we basically had to shift all the n elements to the left, or n minus 1 elements to the left, and that's the reason it takes big O of n time to delete from the beginning. Suppose we were to delete from the middle. Let's say we wanted to delete negative 20. The way we would do that is override negative 20 with its right value, which is negative 30. Override negative 30 with 15. Override 15 with 10. And here the way I'm just deleting it for now, but how we would actually do this in code is basically we would have an end pointer, and the end pointer would basically point here, stating that after this after index 5, everything else is garbage. So even though 10 would be there after index 5, it would not be considered because this is called the end of the array. So the array ranges from index 0 to index 5 and excludes 6 and 7. That's the way we would implement it in code. So I'm just going to delete 10, even though that won't be the case. We could do that. We could delete 10 and override it with some garbage value like infinity in Python if you were to do it, or 0, or anything like that. But yeah, usually we make use of an end pointer. So suppose we were to delete from the end. So we saw deletion from the beginning and deletion at the middle. So deletion at the middle also takes big O of n time, because as we saw, we had to pretty much shift almost n by 2 elements, but this is in the order of n. We ignore all the coefficients and constants when it comes to big O notation, so that's why we ignore this 1/2 being multiplied by n. We just put n. So now let's move on to deletion at the end. Suppose we want to delete 10. The way it would work is we just have to move this pointer, the end pointer, to just after index 4. That means it's indicating that everything after index 4 is garbage. So the array basically ranges from 0 to index 4 itself. So this 10 would not really be considered. So that's the way deletion works at the end. And as you saw, just moving the pointer by one index takes constant time. So deletion at the end also takes big O of 1 time or constant time.